Hi everyone, today I'm going to talk about the geometric isomerism of alkene, cis and chains. Before we get into that, we should know the definition of cis and chains. What's a chains? Chains, for me, chains mean opposite. It's also called E. How about cis? Means same. Cis means same, means opposite side and same side. Opposite side and same side. It's also called Z. And when we look at when we look at when we try to find out which one is the biggest group in each side of the double bond, we're looking for the high priority. The group that have higher priority is the biggest group. Priority means higher atomic number. Higher atomic number. For example, with the bond right here is C83, 8C83. We look at the different side of the bond. We look at the left side and the right side of the double bond. This is the double bond. We look at the left side and the right side. For the left side, which one have higher priority, hydrogen or carbon? Look at this one and this one. Which one? Carbon. So this one is the biggest group for the left side. And for the right side, it's also carbon. What if I give you right here is chlorine? So chlorine has higher priority than carbon. So chlorine is the biggest group for the right side. Okay, go to more specific. Okay, I give you two examples. Before they look like they are the same. They are the same molecules, right? But it's not. They are actually different molecules because they are two different isomers. Even though they look like the same molecule and they have the same name, and what the name for it does, we name it like 1, 2, 3, 4, right? So it's a what? 2-butene, right? And this one is as well 1, 2, 3, 4. So 2-butene. It's a 2-butene. And how? And what's different? It's different. What? The last slide. We're looking for the biggest group first, the higher priority first. And for this molecule, we already defined that these two are the biggest group, right? These two are the biggest group, right? And so change mean different side, right? Change mean opposite, mean different side. So we look at the next one after we look at the left and the right side of the bond. Right now we look at the top and the bottom side because we already have two different sides. So now we look at the size of the double bond. Give me this side right there. Let me go different color. Two different color. See, they both at opposite, like across each other. So it's a what? It's a cis. It's a cis. It's a change. My bad. It's just change. So it should be change. We put at the top right here at the beginning. Change to butene. And how about this? We look at different side. So they are at the same side. They are the same side, right? Of the double bond. So it should be cis. Means same. 2-butene. So now we have two different molecules. But instead of change, you can write down E, means different side. E 2-butene. And right here Z 2-butene. The next example. Here now I give you example of two different molecules. They are not the same. They are different because they have two different isomers. So look at the top one, the number one first. And which ones are the two biggest group? Okay, we divide it by half. Right here, chlorine and bromine are the two biggest groups for the left and the right side of the double bond, right? And for number 2 as well, chlorine and bromine, right? And then now next we look at the top and the bottom, and look at the top and the bottom side of the double bond. For the number 1 molecule, they are across each other, right? Across. It means what? It means chains. Chains or E. And right here, the same side means cis or Z. And what is the name for it? The name for it is like usually we do 1, 2, 3, 4, 5, 6 is 4 bromo, 3 chloro, 3 hexene, right? And 6 the same name for bromo, 3 chloro, and 3 hexene. There are 2 different molecules, and that's it for cis and chains. But be careful. At the first step, when we try to find out the biggest group up the 2 sides of the bond, we should be careful. Okay, now we look at the right side first. We are able to find the biggest group, which is CH3, right? But when you look at the left side, can we find out which one is the biggest group? No, because they are both the same. So the geometric isomerism of alkene is undefined, cannot be determined. So this is only one molecule, and no isomer. Thank you for watching.